close your eyes. The quiet science begins. Tonight, we gently drift into what happens inside a black hole. There is something already happening beneath you that you have never needed to think about. The planet you are lying on has weight, enormous, quiet weight, and that weight does something to the space around it. It bends it, not metaphorically, physically. The fabric of space itself curves downward toward the center of the Earth, and your body rests inside that curve the way water rests inside a bowl. You have never floated away, not once. And it was never because you were holding on. This is not a complicated thing to receive right now. It does not require understanding. You have always been held in this curve, and you are held in it still, at this exact moment, with no effort from you at all. So to begin, there is only this: you do not need to do anything. Not tonight. Not in the next few hours. The science we are going to move through together is not a test, and it asks nothing of you. It is more like a slow walk through something quietly large. Something you have always been part of, even when you had no name for it. Take one breath that is a little slower than the last one. Not forced, just slightly longer on the exhale, if that arrives naturally. Your body already knows how to slow. It has always known. The topic tonight is what happens inside a black hole. And before you picture anything dramatic, before any image from a film or a textbook surfaces, I want to gently set those aside. Not permanently, just for now. Because what we are going to explore is quieter than any image you have seen. It is, in a strange way, closer to the experience of falling asleep than to anything explosive. Black holes are not violent places in the end. They are places where things slow down, where time itself becomes heavy, where light, which has never stopped moving in its entire existence, finally cannot leave. There is something in that, something worth sitting with before we explain anything. For now, there is only the room you are in, the surface beneath you, the ordinary darkness behind your eyes, and the fact that space is curved here, gently, the same way it is curved everywhere mass exists. You are already, in the smallest possible sense, inside that same principle, resting in it, being held by it. Nothing is required of you. The word gravity comes from the Latin gravitas, which meant heaviness, but also seriousness. A kind of quiet weight that commands attention without raising its voice. That feels right. Gravity is the most patient of all forces. It does not push. It does not spark or crackle. It simply draws things toward each other, slowly, consistently, across distances so large we have no natural feeling for them. And it does this not by reaching out and pulling, the way we might imagine, but by changing the shape of the space around it. Einstein understood this over 100 years ago, and the understanding was so strange that even he hesitated over it. Mass, any mass, does not just sit in space. it reshapes space around itself. The way a stone placed on a stretched cloth makes a dip. And other objects near that dip get pulled toward it in any mechanical sense. They simply follow the curve. They move along the new shape of space. This is happening to you right now, to every atom in your body. The planet beneath you is massive enough to curve the space you are occupying. And every part of you is following that curve, resting into it, settling into it. The way any object does when it finds the lowest point of the shape around it. Your body is following the geometry of this planet, quietly, without instruction. There is nothing frightening in this. It is, if anything, the most fundamental experience of rest in the universe, finding the lowest curve and staying there. Which is exactly what you are doing right now. Without trying, without even having known the name for it, until just now. This is where black holes begin, not with explosions, not with darkness, but with this same principle, taken further than Earth ever takes it. A black hole is simply a place where mass has become so concentrated that the curve it makes in space becomes infinite. Where the dip becomes so deep that nothing, not even light, can climb back out. But we are not there yet. There is no hurry. Right now, there is only the curve you are already resting in. The quiet geometry holding every part of you in place. Stars live long, quiet lives. This is something worth knowing before anything else. The ones we see at night. And they are there even when clouds hide them. Even in cities drowning in their own light, most of those stars have been burning for millions or billions of years. Steadily, without pause. The sun you will not see again until morning has been doing the same thing, in the same patient way, for 4.5 billion years. A star is, at its core, a negotiation. On one side, gravity, that same force we have been sitting with. The star's own mass pulling every part of it inward, toward the center, always. On the other side, pressure. The heat of nuclear fusion at the core, where hydrogen atoms are being crushed together into helium, releasing light and energy that pushes outward against all that inward pull. A living star is the balance between those two forces. Neither winning, neither losing, just holding. And for the vast majority of their existence, stars do exactly this. They hold. They burn. They emit light in all directions. Light that travels for years and decades and centuries before it reaches anything at all. Before it reaches an eye, a leaf, the surface of a planet. The light arriving at your window each morning left the sun 8 minutes ago. Not billions of years ago. 8 minutes. That is how close we are. And still, in the scale of the universe, this is an intimate distance. Most starlight travels for far longer. Some of what you would see on a clear night left its source before humans existed. Before this continent had its current shape. Before there were eyes to receive it. there is something about that I keep returning to, quietly. The stars are old enough that their light carries a kind of patience in it. And the black holes they sometimes become, those are what gravity looks like when the negotiation finally ends. But endings in the universe are not what we expect them to be. When a star much larger than our sun reaches the end of its life, something shifts in the negotiation. The hydrogen at the core runs low. Fusion slows. The outward pressure weakens. And for the first time in millions or billions of years, gravity begins to win. The star collapses inward. This happens fast by stellar timescales, seconds in some cases. The outer layers fall toward the center with tremendous force, and what happens next depends on the mass of the star. For the very largest ones, there is a moment where the collapsing core becomes so dense, so compressed, that nothing in nature can resist gravity's pull anymore. Not heat, not pressure, not any force we currently know of. The core continues collapsing, past the density of a neutron star, past any state of matter we can produce in a laboratory, past any threshold we have a name for, into what physicists call a singularity. Now, the word singularity is used carefully in physics. It doesn't mean something mystical or unknowable in a dramatic sense. It means a point where the mathematics we use to describe physical reality breaks down. It means we have reached the edge of what our current tools can describe. Not the edge of what is real, just the edge of what we can currently map. A singularity is, in the gentlest interpretation, a reminder that our maps are not the territory. This is worth sitting with. Our most precise, most beautiful equations, the ones that described the curve of space, that predicted black holes decades before we observed them, those equations, at the singularity, return an answer of infinity. And infinity, in physics, usually means something is happening here that we do not yet have the language for. Not chaos, not nothing. Just a place where known language ends and something else continues. The body knows this feeling too, the edge of sleep, where thinking dissolves not into absence, but into something else that has no precise name. You are near that edge now. Perhaps there is no need to name it. Before anything can fall into a black hole, it must first cross a boundary. Not a physical wall. Not a membrane you could touch or see. Just a threshold. An invisible sphere surrounding the collapsed core, beyond which the curve of space has become so steep that the escape velocity exceeds the speed of light. Escape velocity is the speed something needs to reach in order to leave a gravitational field. To leave Earth, a rocket needs to travel about 11 kilometers per second. To leave the surface of the sun, faster. To leave a black hole, any black hole, you would need to travel faster than light. And nothing travels faster than light. So, nothing escapes. This boundary is called the event horizon. And the name is precise in a way that repays attention. An event is anything that happens, any occurrence, any moment in time and space. A horizon is the limit of what can be seen from a given point. The event horizon is the limit of what any observer outside can ever know about. Events that happen beyond it, things that occur inside, will never send information back. Not because they are hidden, but because the geometry of space there makes outward travel geometrically impossible. The information simply cannot move in the direction it would need to move. It is not a wall. It is a one-way shape. From the outside, you would see something strange if you watched an object approach it. The object would appear to slow. Not because it is actually slowing, but because the light leaving it takes longer and longer to climb out of the deepening curve of space. The object reddens as its light stretches. It dims. And eventually it appears to stop entirely, frozen at the horizon like a photograph. But from the inside, from the perspective of anything crossing that threshold, nothing dramatic happens at the moment of crossing. No wall, no jolt. Just a continuation. Just the next moment. The horizon passes around you, not through you. And then the interior. What lies inside is what we will walk toward now. Slowly. Without urgency, with the same quiet patience that gravity itself carries. Drawing things inward, not with force, but with the simple, irresistible depth of the shape it has made. The interior of a black hole is not dark in the way a room is dark when the lights go out. Darkness, as you have known it your whole life, is the absence of light in a space that light could otherwise fill. Close your eyes in a lit room, and you have darkness, but the light still exists, just beyond your eyelids. Step into a cave, far from the entrance, and the darkness is more complete. But light still exists beyond the stone. Every darkness you have ever experienced has been a local condition. Light was always somewhere nearby. Inside the event horizon, the situation is different in kind, not just degree. Light still exists there. Photons are still moving at the speed of light. They never stop. They never slow. This is one of the fixed things in nature. But the geometry of space inside the horizon is arranged in such a way that all directions of travel lead deeper inward. Not just downward in the gravitational sense. All directions. The paths through space that photons follow. Paths that normally radiate outward in every direction from a source. Inside the horizon, those paths all curve toward the center. There is no direction that leads out, so light moves, constantly, energetically, and still accumulates inside. Not because it is trapped the way a bird is trapped in a cage, but because the shape of space itself has only one direction left in it. This is a strange thing to hold. Normally, space presents us with 6 directions, forward and back, left and right, up and down. We move through them freely, choosing. Inside a black hole, that freedom changes. One spatial dimension, the one pointing toward the singularity, becomes something more like time. Unavoidable. Non-negotiable. The way you cannot choose not to move forward in time right now. A traveler inside the horizon cannot choose not to move toward the center. This is not a sensation of being crushed toward something. It is a restructuring of what direction even means. The center becomes, in a technical sense, the future. Time, before we move deeper, deserves a moment of quiet attention. We treat time as a backdrop, a constant stage on which events occur. We imagine it ticking steadily, the same 1 second per second everywhere, for everyone, always. This is how time feels from inside a single human life. Steady, metered, reliable. But this is not how time actually behaves. Time moves differently depending on where you are in a gravitational field. Clocks at higher altitudes, further from Earth's center, run slightly faster than clocks at sea level. Not metaphorically. Measurably. The GPS satellites orbiting Earth have to account for this in their programming, or their position calculations would drift by kilometers each day. The correction is small, but it is real, and without it, the technology fails. Time is not fixed. It is local. It is affected by gravity. The deeper you go into a gravitational field, the slower time runs, relative to an observer outside it. At the surface of a neutron star, time would pass noticeably slower than here. Near the event horizon of a black hole, the difference becomes extreme. An observer watching from a safe distance would see a clock falling toward the horizon slow dramatically, appearing to freeze at the threshold. And inside, time continues for the traveler. Their heartbeat still counts seconds. Their thoughts still move in sequence. But the relationship between their time and any outside observer's time has broken down entirely. This is not a poetic statement. It is a geometric one. The equations that describe space-time near a black hole show that time and space inside the horizon have exchanged roles in a specific mathematical sense. What was a dimension of space becomes the dimension that flows like time. What was time? That steady forward movement becomes something with more spatial qualities. Not reversible, but different in character. This is the part I keep returning to quietly. Now rest with something that requires no effort to understand, only to receive. You have never experienced time as the same for your entire body simultaneously. This sounds strange, but it is true. The cells in your feet are fractionally deeper in Earth's gravity than the cells near the top of your head. By Einstein's equations, time runs infinitesimally slower for those cells. Not enough to matter in any practical sense over a human lifetime. But the difference is real and physical. Your body is not one place in a gravitational field. It occupies a small gradient, a tiny range of depths. This is not something to visualize with effort. It is simply true of you, right now. In the same quiet way that your cells are exchanging oxygen, your neurons are maintaining their charge. Your heart is completing its cycle. Without your attention, without your participation, there is a version of reality available to physics, not to ordinary perception, but to the mathematics, in which the atoms at the crown of your head and the atoms at the soles of your feet are experiencing the passage of time at slightly different rates. They have always done this. They are doing it now. Inside a black hole, this gradient becomes vast. An object of any size, a stone, a spacecraft, a person, would experience different rates of time across its own structure. The difference in gravitational pull between the near side and far side of any object, the force called tidal force, would be enormous near a stellar mass black hole. Near smaller black holes, it would tear objects apart before they even crossed the horizon. Near a supermassive black hole, the kind at the center of a galaxy, millions or billions of times the mass of a sun, the horizon is so large that tidal forces at the crossing point are relatively mild. An object could cross without distress. It would not know, by feel, that it had passed the threshold. Only the geometry would know. The size of a black hole is worth understanding in a particular way. When we speak of size here, we are speaking of the event horizon, the boundary, not the singularity at the center. The singularity itself is, mathematically, a point, a location without dimension. But the horizon is a surface, spherical, invisible, defined entirely by the mass within it. The formula that describes this is one of the simplest in all of general relativity. The radius of the event horizon, called the Schwarzschild radius, is directly proportional to the mass. Twice the mass, twice the radius. This linear simplicity is almost surprising in a domain where most things are complex. For the mass of the Earth, compressed to a black hole, the event horizon would have a radius of about 9 millimeters. The entire mass of this planet, everything from the iron core to the oceans to the atmosphere, compressed into a sphere smaller than a marble. For the Sun, the Schwarzschild radius is about 3 kilometers. All that mass, the star that holds every planet in the solar system in orbit, compressed into a sphere about the size of a small hill. For the black hole at the center of our galaxy, Sagittarius A star, the event horizon spans roughly 12 million kilometers. A sphere so large that the distance from Earth to the Sun could fit inside it with room remaining. And for the largest black holes we have observed, some billions of times the mass of the Sun, the event horizon spans distances that would swallow not just our solar system, but neighboring ones. These are not numbers to hold with effort. They are simply textures of scale. The universe contains structures at every size. Some of those structures are invisible. Some are larger than anything your imagination was designed to picture. And all of them follow the same quiet mathematics, the same curvature of space. That is holding your body to this surface right now. The question of what an observer actually experiences, falling through a horizon and continuing toward the singularity, is one that physics approaches with care. What we know from the mathematics is this: crossing the horizon is not, in itself, a moment of destruction. For a large enough black hole, the crossing might be seamless, a continuation of freefall that began far outside. The traveler would be weightless. In freefall, there is no sensation of gravity. Astronauts in orbit feel none. Even though gravity is very much present, it simply acts equally on every part of them. So there is no relative pull, no feeling of weight. A traveler falling into a black hole would, in their own reference frame, feel weightless. They would see the universe outside, the stars, the light, still visible ahead of them, gathered into a shrinking circle of view as the horizon closes in from behind. The universe would not vanish. It would compress into a window, growing smaller as the geometry reorganized their relationship to it. And ahead of them, the interior, which appears not as darkness, but as a continuation. The same laws of physics holding. The same atoms behaving. The same passage of experience, moment by moment. For a time. What changes is time itself, in that strange technical sense we touched on before. The future inside the horizon is no longer open. It has a location. It has coordinates. The singularity is not in the distance the way a destination is in the distance when you travel by ordinary means. It is in the future, and the future is unavoidable. How long that future lasts depends on the size of the black hole. For a stellar, mass black hole, microseconds of proper time. For a supermassive one, hours. A long, quiet descent through a region of space unlike any other, toward a place where current physics cannot follow. The body is somewhere like this now, in its own way, moving toward rest, moving along a gradient that only goes one direction at this hour, not forced, just following the shape that sleep has made. There is a question that physicists have turned over for decades, quietly and with some persistence, about what the interior of a black hole actually contains. Not the singularity. We have already acknowledged that the singularity is where the map ends, where the equations return infinity, and the territory continues without us. But the space between the horizon and whatever lies at the center, that region, that interior, physicists have studied it with the tools available. And what they have found is not emptiness. Space, even ordinary space, is not empty. This is one of the more quietly remarkable findings of the last century of physics, and it arrives without fanfare in most accounts. Quantum mechanics, the physics of the very small, tells us that what we call a vacuum is not the absence of things. It is a field, a quantum field in its lowest energy state, but still a field, still active, still fluctuating at every point in space, at every moment. Pairs of particles flicker into existence and vanish again, too briefly to observe directly, but real enough to have measurable effects on the atoms in your body, on the light emitted by stars, on the behavior of electrons in the machines that built the device you use today. The vacuum is not still. Inside a black hole, this same field exists. The same flickering. The same baseline activity of a universe that does not know how to be completely at rest. The interior is not a place of nothing. It is a place where all of the usual activity of space continues, reorganized around a geometry that has no precedent elsewhere. What that activity looks like, what it would mean to exist there, is something we do not yet have the language to describe precisely. But the absence of language is not the same as absence. Stephen Hawking spent years working on a question that connects the inside of a black hole to something unexpected: thermodynamics, the science of heat. It began with an observation about entropy. Entropy is the measure of disorder in a system. More precisely, it is the number of ways a system can be arranged internally, while still appearing the same from the outside. A room with books stacked neatly has lower entropy than a room with books scattered across the floor. There are many more ways to scatter books than to stack them. Disorder has more configurations than order. The second law of thermodynamics says that entropy in a closed system tends to increase over time. Order naturally disperses. Things tend toward more configurations, not fewer. This is not a law anyone chose. It is a statistical reality. There are simply more disordered states than ordered ones. And so random processes tend toward disorder the way a balanced coin tends toward landing differently each time. Hawking, working alongside the physicist Jacob Bekenstein, found something that should not have made sense. But did black holes have entropy? Not metaphorically. Precisely. The entropy of a black hole is proportional to the area of its event horizon. Every bit of information about every object that has ever fallen in, the temperature, the composition, the history, contributes to a quantity written on the surface of the horizon, not the interior. The surface. This is a strange result. Information in physics is a physical quantity. It is conserved the way energy is conserved. It cannot simply disappear. And yet things fall into black holes. And the question of where their information goes, whether it is destroyed, preserved, or transformed into something else, is one of the deepest open questions in all of physics. There is something about this that has always stayed with me. Hawking radiation arrives from this same territory at the intersection of quantum mechanics and gravity, near the event horizon, where quantum fluctuations are producing particle pairs at every moment. Something unusual can happen. A pair forms, one particle and its antiparticle. at the edge of the horizon. In ordinary space, they would annihilate each other almost immediately. But here, the geometry intervenes. One particle falls inward, across the horizon. The other escapes outward into the universe. From the outside, this looks like the black hole is emitting radiation. Not from its interior. Nothing comes from the interior. From the horizon itself, from the edge, from the place where quantum uncertainty meets the absolute boundary of space-time curvature. This radiation, Hawking radiation, carries energy, and energy is mass by Einstein's equivalence. So the black hole emitting this radiation slowly loses mass. Over time, over vast, patient, cosmological time. A black hole that absorbs nothing will eventually radiate away. It will shrink, and when its mass becomes small enough, the radiation intensifies, and it ends in a final brief burst of energy for a stellar mass black hole. This process takes longer than the current age of the universe by many orders of magnitude. We have never observed it. We may not for an almost incomprehensible span of time. But the mathematics says it happens. Black holes are not permanent. They are patient. They are, in a sense, the longest exhale in nature. The information paradox. What happens to the information carried by everything that falls into a black hole remains unsettled. 3 broad possibilities have been considered, and each of them says something interesting about the nature of reality. The first information is destroyed. Everything that falls in, every atom, every arrangement, every history is erased at the singularity, gone from the universe. This conflicts with quantum mechanics, which treats information as fundamentally conserved. Most physicists resist this option, not because it is emotionally uncomfortable, but because it breaks mathematics that works extraordinarily well everywhere else. The second information, is preserved in the Hawking radiation. Somehow, the particle pairs that form at the horizon carry encoded information about what fell in. The radiation leaving the black hole is not truly random. It is subtly, complexly patterned in ways that preserve, at least in principle, everything the black hole ever swallowed. This is possible, but requires understanding we do not yet have about how that encoding works. The third, information is preserved somewhere else entirely. Some versions of this involve the idea that the information is held on the horizon itself, that the surface of a black hole is a kind of hologram encoding the full 3-dimensional contents of the interior on its 2-dimensional boundary. This is the holographic principle, and it emerged not as speculation, but from serious attempts to unify general relativity and quantum mechanics. The universe may, in some deep sense, store its information on surfaces rather than in volumes. The interior may be, in some precise mathematical sense, a projection of what is written on the boundary. This idea extends, in some theoretical frameworks, beyond black holes. It suggests that our own experience of three-dimensional space may have an equivalent description in 2 dimensions. On some surface we cannot see or directly access. You are not required to resolve this tonight. There is something worth holding about the relationship between black holes and the galaxies around them. Most large galaxies, including our own, are understood to contain a supermassive black hole at their center. Not suspected, observed. In 2019, the Event Horizon Telescope, a network of radio dishes coordinated across the planet, effectively making Earth itself into a telescope, produced the first direct image of a black hole's shadow. The black hole at the center of the galaxy M87, 5 million light-years away. A shadow in light, a dark circle against a ring of glowing gas, exactly as the mathematics predicted. In 2022, a second image followed. Sagittarius A star, the black hole at the center of our own galaxy, 26,000 light-years from here. A quiet, ancient mass that has been at the center of everything we are part of for as long as the galaxy has existed. It is not consuming the galaxy. It is not threatening us. It sits at the center as it has always sat, its gravity woven into the orbital structure of hundreds of billions of stars, including the one this planet orbits. The structure of a galaxy is partly a story of how matter organizes itself around gravity over billions of years. Clouds of gas collapse into stars. Stars orbit the common center. Mergers happen, slowly, over timescales that dwarf anything in human history. And at the center of many of these structures, a mass so compact it has crossed the threshold. Present, stable, integrated into the fabric of everything around it. Our galaxy is not spinning around an absence. It is spinning around something that cannot be seen, but whose influence is woven into every orbit, every star, every dark, quiet edge of the spiral. You have been part of that spiral at this particular address for your entire life. The galaxy has been turning around that center for longer than the solar system has existed. Rest in that for a moment. Not as a thought, just as a quiet fact, received without needing to do anything with it. There is a particular thought that arrives sometimes when you stay with black holes long enough. Every atom in your body was forged inside a star. This is not a new idea, and perhaps you have heard it before. But hearing it and resting inside it are different experiences. The carbon in your cells, the calcium in your bones, the iron moving through your blood right now. None of it existed when the universe began. The early universe contained hydrogen, helium, and trace amounts of lithium. Everything heavier was built later, inside stellar cores, by the same fusion process that holds a star in balance against its own gravity. When stars die, particularly the large ones, they return that material to space. Supernovae seed the surrounding region with elements. Clouds of enriched gas drift and cool over millions of years. And eventually gravity gathers them again into new stars, new planets, new arrangements. The solar system formed from such a cloud that had already been through at least one stellar generation before our sun ignited. Everything solid in this system, this planet, its oceans. The surface you are lying on, is second generation stellar material. You are made of what a star released when it could no longer hold. And the black holes left behind by those same dying stars, they are the other product of that same ending. The material that went outward became the universe we inhabit. The core that collapsed inward became something else. Two outcomes from a single event. You are, in the loosest sense, the scattered counterpart of the collapsed. Light bends around black holes in ways that produce effects with a specific name. Gravitational lensing. When light from a distant object, a galaxy, a star, passes near a massive object on its way to us, the curvature of space deflects its path. The light does not travel in a straight line, because space itself is not straight in that region. It curves around the mass, and what we see is not the original position of the source, but an image shaped by the geometry it traveled through. Around black holes, this becomes extreme. A black hole can produce multiple images of a single source, the light, reaching us by several different curved paths simultaneously. It can produce arcs, rings, even a complete circle of light, if the alignment is precise enough. This ring is called an Einstein ring, and we have observed several of them. There is a radius around a black hole, outside the event horizon, where gravity is strong enough that light can orbit. Not escape, not fall in, but circle. A photon sphere, where light that enters at exactly the right angle will travel in a circle indefinitely, until something disturbs the orbit. Imagine a beam of light that has been circling a black hole for millions of years. Not trapped, orbiting. Moving at the speed of light, completing circuits of an invisible track around an invisible center, in a region of space that no human has visited or ever will. This is not a metaphor. This is a calculated prediction of general relativity, confirmed indirectly by observation. Light, the fastest thing in nature, made into something like a planet for a time. Black holes occasionally eat. Not constantly, not dramatically, but when gas or dust or a star wanders too close, material begins to fall inward, and as it falls, it accelerates. As it accelerates and compresses, it heats. As it heats, it radiates. The region around a black hole, where material is spiraling inward, compressing, heating, this is called an accretion disk, and it is among the brightest structures in the observable universe. A black hole itself emits no light, but the material falling into one can outshine entire galaxies, quasars, observed first in the mid-20th century as point sources of light, so bright they initially defied explanation. are the cores of distant galaxies, where supermassive black holes are actively consuming large amounts of material. The energy released by that consumption, converted to radiation by the heating and compression of the accretion disk, makes them visible across billions of light years. The most distant objects we have ever observed are quasars. Light that has been traveling toward us for most of the age of the universe, carrying the signature of a black hole feeding at the center of a very young galaxy. When we observe them, we are seeing the universe as it was when it was young, before it had settled into the quieter rhythms it has now. The universe was louder once, more active, more material in motion. It has calmed. Over billions of years, the way most energetic things calm. Stars still form, but fewer than before. Black holes still consume, but the supply has thinned. The background hum has lowered. Even on cosmic scales, things settle. There is a concept in the physics of black holes called spaghettification, and it has a precise meaning beneath its informal name. Tidal forces, the difference in gravitational pull between the near side and far side of an object, stretch things. The moon creates tidal forces on Earth that stretch the oceans into the elongated shape that produces tides. The difference in pull between the side of Earth facing the moon and the side facing away is small relative to Earth's own structural integrity. So Earth holds its shape, and only the fluid surface responds noticeably. Near a stellar mass black hole, tidal forces become enormous at the horizon. The difference in gravitational pull across even a small object would be extreme enough to stretch it lengthwise while compressing it sideways, pulling it into a long, thin strand. A stone, a person, a spacecraft would be drawn out into something thin and continuous, like a thread, long before crossing the event horizon. For a supermassive black hole, as noted before, the horizon is so distant from the center that tidal forces at the crossing point are gentle. The stretch is real but mild. A traveler could cross intact. The body has its own version of this, not dramatic, but present. When you lie flat, your spine decompresses slightly. The discs between your vertebrae, compressed during the day by the body's weight and activity, absorb fluid slowly during the night. You are, in a very small and benign sense, slightly longer in the morning than when you went to sleep. Gravity's differential across your height allows a quiet expansion. You have been gently lengthening since you lay down. There is a theoretical boundary inside a rotating black hole, and most black holes are expected to rotate, called the Cauchy horizon. A rotating black hole, described by the Kerr solution to Einstein's equations, has not one boundary but two: the outer event horizon, which we have already walked through together, and an inner boundary, deeper inside, where the mathematics of space-time becomes particularly strange. At the Cauchy horizon, The equations suggest that the future becomes non-unique. That is the precise language physicists use. Normally, the laws of physics are deterministic in a specific sense. Given the current state of a system, the equations predict a unique future. One path forward from any given moment. At the Cauchy horizon, this uniqueness may break down. Multiple futures become mathematically consistent with a single past. The equations stop predicting one outcome and begin permitting many. Whether this is physically real or a signal that the equations are incomplete, whether the Cauchy horizon would destroy anything that reached it or allow passage remains an open question, argued carefully in papers and at conferences and in the quiet of offices, where people spend their lives on problems of this kind. What it suggests, at minimum, is that the interior of a rotating black hole may contain regions of space-time where the ordinary structure of cause and effect becomes something more open. Where the future is not a single track, but a field of possibility. The mind, near sleep, does something similar. The strict sequencing of waking thought relaxes. One thing does not follow the other so precisely. The future of the next image is not determined by the last. Things can arrive from anywhere. You may already be there, or near it. The universe is approximately 13.8 billion years old. This number is offered not as a fact to hold with effort, but as a kind of background. The way a room has dimensions you do not think about while you are inside it. The universe has been doing what it does for that span. Stars have formed and ended. Galaxies have collided slowly over hundreds of millions of years and merged into new shapes. Black holes have grown. Space itself has expanded, carrying everything inside it outward in all directions simultaneously. And through all of that, the full span, every stage, the same physics has been operating. The same curvature of space. The same quantum fluctuations in the vacuum. The same conservation of energy. The same fundamental forces. The same mathematics underlying everything from the behavior of a hydrogen atom to the orbital dynamics of galaxy clusters. You are a product of that entire span. Not a distant product, not a late arrival standing apart from the process. A current expression of it. The atoms in your body have been part of this universe for its entire existence. Hydrogen atoms in your cells are as old as the first minutes after the beginning. The heavier elements were built later, inside stars, but those stars themselves were built from material that was there from nearly the start. Nothing in you is new to the universe. Every part of you has been here the whole time, in different forms, in different arrangements, but here, present, participating. The black holes forming, now from dying stars, are using the same physics that shaped the material you are made of. The same negotiation between gravity and pressure that ended in a supernova, that released the material that eventually became you also left behind a collapsed core. You and that remnant came from the same event, in the broadest sense. You are the scattered version. It is the held version. There is a way of thinking about identity that physics makes available quietly. We tend to feel ourselves as continuous. The same person who woke up this morning, the same person who was a child, the same person who will wake tomorrow. This feeling of continuity is real and valuable. It is how experience accumulates, how learning happens, how relationships hold over time. But the material continuity of the body is different from what we expect. The atoms in your body are not the same atoms that were there 7 years ago. Some are replaced faster, some slower, but the material is in constant exchange with the environment. You breathe in atoms that were in a tree last month, in the ocean last year, in the atmosphere of a different continent before that. You exhale atoms that will become part of something else. The boundary of the body is a boundary of pattern, not of material. You are a shape that matter moves through. A stable, self-maintaining arrangement, extraordinary in its complexity and persistence, but not a fixed collection of specific atoms. More like a standing wave in a river than a stone. Black holes are similar in a way that is worth noticing. A black hole is not a collection of the specific material that fell into it. The material that formed it is gone, absorbed into the singularity, into the place where our description ends. What persists is the gravitational signature, the curvature of space, the information encoded on the horizon. The black hole is a pattern maintained by geometry in the absence of the original material. Both of you, the pattern that is you. Others call the pattern that is a black hole are structures persisting through change. Neither of you is your original material. Both of you are your shape. The Milky Way and the Andromeda Galaxy are moving toward each other. This is not alarming. It is slow, a collision in the astronomical sense, which means it will begin in roughly 4 billion years and unfold over another billion or 2 after that. The two galaxies will pass through each other. Their stars too spread out to collide directly in most cases. Their structures disrupted and eventually merged into a single larger galaxy. The black holes at their centers, Sagittarius A, star, and the larger black hole at Andromeda's core will eventually spiral toward each other and merge. Two singularities becoming one. Two event horizons merging into a single, larger boundary. The process will release gravitational waves, ripples in space-time itself, the same kind we have now learned to detect with instruments sensitive enough to measure distortions smaller than a proton across a distance of kilometers. Gravitational waves from merging black holes have been detected. The signal from the first confirmed detection in 2015 was a chirp, a rising frequency lasting a fraction of a second. encoding the final moments of two black holes spiraling together 1 billion light years away. 1 billion light years. The sound, translated from gravitational waves to audio, was less than a second long. The event it described took place when the most complex life on Earth was still single-celled. That signal passed through everything, through the planet, through the space where this continent would eventually form, through the space where you would eventually exist. It arrived at the detectors after traveling for 1 billion years, and we heard it. The universe has been sending signals through us for our entire existence. We have only recently built instruments sensitive enough to notice. Sleep is not the absence of the brain's activity. This is worth knowing quietly. During sleep, the brain does not go dark. It reorganizes. Certain networks that are active during waking hours quiet down, and others become more active. Memory consolidation happens during sleep. The events and information of the day are processed, sorted, some retained and strengthened, some allowed to fade. The brain, without the demands of waking perception, does a kind of maintenance that it cannot do while managing the flow of moment-to-moment experience. There are stages. Light sleep, where the body begins to release its waking tension. Deeper sleep, where brain waves slow to long, rolling rhythms, where the body does much of its physical repair. And REM sleep, rapid eye movement, where the brain becomes active again, vivid, producing the experiences we sometimes remember as dreams. In REM sleep, the prefrontal cortex, the region most associated with logic, planning, critical evaluation, is less active than during waking. The regions associated with emotion, memory, and sensation remain engaged. This is partly why dreams feel real and do not feel strange in the moment. The part of the brain that would notice inconsistencies and question them is, for that time, quieter. The brain during sleep is doing something black holes do as well, in a structural sense, taking in what has arrived, processing it through internal geometry, and storing what persists in a form that will shape what comes next. Neither the sleeping brain nor the black hole is passive. Both are actively working with what they have received. You are already in the early stages of this. The body is beginning its own processing. The day is being sorted somewhere below the threshold of effort. There is something that happens near sleep that most people experience without having a name for it. In the transition between waking and sleep, hypnagogia, the technical term. Though the term matters less than the experience, the mind produces images, sounds, sensations that arrive unbidden and feel briefly real before dissolving. A face you do not recognize, a sound that makes you startle slightly before the body releases it, a sense of stepping or falling just at the edge, which sometimes brings you briefly back. This stepping sensation, the hypnic jerk, is common, benign, and its origins are debated. One account suggests it may be a kind of artifact of the transition, the motor system momentarily activating as the usual inhibition of sleep settles in. The body checking, in a sense, that it is still intact before releasing its waking vigilance. It is, if anything, a signal. The body at the threshold doing one last check and then letting go. The event horizon of a black hole is also a threshold where the usual rules of checking, of sending information back, of knowing what is on the other side, come to an end. Beyond it, the interior continues, but no signal can return to confirm it. The universe outside cannot know what is happening inside. Not because nothing is happening, but because the geometry no longer permits the message to travel outward. Sleep has something of this quality. The waking mind cannot fully observe what the sleeping mind does. The processing happens. The consolidation happens. But the waking self will not have access to most of it. A few fragments may surface as dreams. The rest is interior, real, consequential, and beyond the reach of waking observation. Both are forms of necessary interiority. Both are where much of the actual work happens, out of sight, in the dark. In the deep, your body knows how to do this. It has done it every night of your life. The information is quieter now, not gone, just further away. The way a conversation in another room becomes a murmur, and the murmur becomes a texture, and the texture becomes simply part of the background of being somewhere warm and still. Black holes are still out there. They have not changed. Sagittarius A star sits at the center of the galaxy, as it has for billions of years, holding its quiet geometry, curving space in its patient way. The supermassive structures at the centers of distant galaxies continue their slow accumulation. Somewhere, two smaller black holes are spiraling toward each other. Not urgently, not dramatically, just following the curve of space-time toward an eventual merging that will ripple outward in gravitational waves across 1 billion years of space. All of that is continuing right now without your attention. The universe does not require observation to proceed, and neither does your body. The systems running in you right now, the slow wave of digestion, the breath moving in and out without instruction, the heart completing each cycle with the same quiet reliability. It has maintained every moment of your life. None of it needs you to be awake to continue. You can release the waking part, the part that monitors and plans and checks. It has done its work today. The breath is a useful thing to notice, without changing it, just the fact of it. Air arriving, the slight pause. Air leaving, the slight pause before the next one. This has been happening since you were minutes old, in a hospital or a room. Somewhere, when the first breath arrived and the body understood what to do with it. Tens of millions of breaths since then, each one unremarkable. each one keeping the whole arrangement going. The oxygen in that breath will reach every cell. It will participate in the chemistry that maintains the temperature, the charge, the structural integrity of everything you are. And the carbon dioxide leaving, that will go out into the room, and then further into the atmosphere, and eventually some of it will be taken up by something green and growing, and incorporated into a leaf, and that leaf will participate in its own life for a season. The breath connects you to the cycle. It always has. Inside a black hole, there are no cycles of this kind. No exchange. No outward breath. The geometry permits only inward movement. But here, on this surface, in this room, the exchange continues freely, in and out. Open system. Participant. The body is exchanging itself with the world, breath by breath. The jaw can soften now, if it hasn't already. Sometimes the jaw holds tension that accumulated so gradually through the day that it no longer registers as tension. It simply became the resting position. A subtle clench, a slight forward pressure of teeth on teeth, a tightness in the hinge. It can release. There is nothing to hold there. The muscles around the eyes, too. The small ones, the ones that have been processing light and movement and expression all day. They have done a great deal. They can be still now. The weight of the head on the surface beneath it. That weight has been supported all day by the neck and the muscles along the spine. Now the surface is doing that work. The muscles can acknowledge this and soften into it. The same gravity that curves space, that holds galaxies in their structure, that kept every ancient star in its balance, that same force is pressing your body gently into the surface right now. Not dramatically, not urgently, just steadily, as it has pressed everything toward everything else for the entire history of the universe. You are resting in the oldest force there is. Somewhere in the observable universe, a star is ending right now. Not a dramatic statement, a statistical one. Stars end constantly, across the vast number of galaxies we can observe. Some quietly, shrinking into white dwarfs that cool over billions of years. Some in supernovae, seeding space with the elements they spent their lives building. And some, the large ones, collapsing into black holes, adding one more region of closed off space-time to the universe. One more place where the interior continues without sending any signal back. One more patient structure, holding its geometry, curving the space around it, influencing the orbits of anything nearby, for as long as it persists. Which, as we said, is a very long time. You will not be awake for most of it. That is fine. Most of the universe proceeds without witnesses. Most of what happens in the interior of any black hole will never be observed by anything. Most of what happens in the interior of a sleeping mind will not be remembered. Most of the work of a living body on any given night will not register as experience. Things happen in the unobserved interior. Real things. Consequential things. The universe permits interiority. There is one more thing, offered quietly, before the words thin out entirely. You have spent this time moving through something enormous. The curvature of space-time. The collapse of stars. The geometry of a region where all directions lead inward. The slow radiation of a black hole across timescales that exceed everything human. The flickering of quantum pairs at the edge of an event horizon. The information written on a surface. The merging of distant black holes and the ripples they send across a billion years of space. And underneath all of it, underneath the scale, the mathematics, the strangeness, one simple fact kept returning: gravity holds things. Quietly, without urgency, without announcement. It simply makes a shape, and things rest into that shape, and they stay. You have been held that way tonight. You have been held that way your entire life. The planet beneath you is not neutral. It is actively, continuously, curving the space you occupy toward itself, holding the geometry of your resting place, making the shape that keeps you here, on this surface, in this room, in this night. The same principle that makes a black hole makes your sleep possible. You are resting in the geometry of this world. The shoulders can be heavy now. They are allowed to be heavy. The full weight of them released into the surface. The breath doing its quiet work. The body knowing everything it needs to know about rest. Somewhere, 13.8 billion years of physics is continuing in every direction at once. Stars burning, space expanding, black holes holding their patient interiors in the dark. And here, in this small, warm room, on this curved surface of a spinning planet, one person is crossing their own threshold, not into nothing, into the interior, where the work continues, quietly, without witnesses, without urgency, without any need to return a signal. Sleep well. The universe will be here when you come back.